A groundhog's hole is 248 feet from the base of a tree. If the groundhog peeks his head out of his hole and looks up at the top of the tree at an angle of 6.9 degrees, what is the height of the tree? For a problem like this, it's a good idea to go ahead and draw a picture of what we've been given. That way we can lay out all the pieces, and that may help us figure out how to solve this problem. Now first, we've been told that a groundhog's hole is 248 feet from the base of a tree. So let's go ahead and draw that out. Here, we'll have our tree. And if we go 248 feet from the base of this tree, we get a groundhog's hole. So here we have the hole, and we have the groundhog peeking his head out of the hole, just like this. Great. Now, we're told that the distance from the base of the tree and the groundhog's hole is 248 feet. Now, we're also told that if this groundhog peeks his head out of the hole and looks up at the top of the tree, that angle created is 6.9 degrees. So, if we draw that out, here is what we get. This angle is 6.9 degrees. It's created from the ground and that line from the groundhog to the top of the tree. This is an angle of elevation. Now, from this information, we're trying to figure out the height of the tree. That would be this height right here, going from the top of the tree straight down to the base. So, let's say that that measures h. That is what we're trying to find. Now, how do we do that? Well, look at what we've made. We've actually created a triangle. And this height goes straight down to the level ground. So this is a right angle. That means we're actually looking at a right triangle. And we know quite a bit about right triangles. If we look, we have this angle, that angle of elevation. And we also know the measurement of this side. We're looking for the measurement of this side, h, that height of the tree. Well, if we have at least one angle measurement and at least one side measurement, we may be able to use a trigonometric or trig ratio to help us find the length of that missing side. So let's see if we can come up with a trig ratio that would help. Well, let's see. Again, we have this angle, and we have the measurement of this side. That side sits next to or adjacent to our angle. And we're trying to find the measurement of this side. That side sits across or opposite our angle. Well, with an opposite side and an adjacent side, it looks like the tangent ratio might be useful to us. To find tangent of an angle, we need to take the opposite side over the adjacent side. So let's find all the different pieces and then plug them into this ratio. Here, x is our angle. We're looking at this, our angle of elevation. So x is 6.9 degrees. The opposite side sits across from our angle. That's h. That's the measurement that we're looking for. And the adjacent side sits next to our angle, but is not the hypotenuse. Our adjacent side measures 248 feet. Now that we have all this information, let's go ahead and plug it in to that tangent ratio and see what we get. So we end up with tangent of 6.9 degrees is equal to the opposite side, which is h, over the adjacent side, which is 248 feet. And now look at what we have. With this equation, we could solve for h and figure out what h, that height, is equal to. So let's go ahead and solve this equation for h. To do that, we need to get h by itself on one side of the equal sign. So we need to take this 248 and move it to the other side. To do that, we perform the opposite operation. Right now it's being divided, so we need to multiply it on both sides in order to move it. Over here we get 248 times tangent of 6.9 degrees. And over here, we're just left with h. So let's simplify and figure out what h is equal to. If we take tangent of 6.9 degrees and approximate that with our calculator, then multiply by 248, we get approximately 30.011. Now we're working in feet, and this is the height of the tree. So we need to put feet in our answer. So here, we now have what h is approximately equal to. Now, some of these problems may ask you to round to a certain place. This one didn't. So here, this would be an appropriate answer. Or we could even round this and say that the height of the tree is about 30 feet. That would also be an appropriate answer. So now, we have taken our given information and used a little bit of trig to help us find the height of this tree. We found the height of this tree to be about 30 feet.